In this next video, nothing new. Let's just get some more practice using things with log scales. Example 5 says to plot the following values, planets and their average distance from the sun on a log scale. So we've got all the planets, all their distance in millions of kilometers, and rest in peace, Pluto, not a planet anymore. So let's graph this on a log scale. So what's going to be useful, right? These are our data points. All right. And so on the log scale, we're going to have capital X's essentially. We can do it just like we did it before. Okay, so we'll have we can have like 10 to the 0th power, 10 to the 1st power. Because what's our smallest number on a log scale? Remember, capital X is the logarithm of little x. So the smallest number that we have to have is the logarithm of 58. The smallest number we need is the logarithm of 58. That's about 1.8 about. Okay. And what's the biggest one we need is the logarithm of 4,500. That's about 3.7 about. Okay, so we can have 10 to the 1st here, 10 squared here, 10 to the cubed here, 10 to the 4th here, log scale. These are our little x's. We're not growing linearly anymore, we're growing exponentially, multiplying by 10 every time. Or if you wanted, you could also include capital X, which would just be 1, 2, 3, and 4. So let's plot everything. 1.8, that's our first one. That's going to be Mercury. 3.7, that's our last one. Going to be Neptune. So go ahead and plot all the other planets on this line. Pause the video. How are you going to plot these other planets? And let's see if we get the same answer. If you do that, we're going to have to find the exponents for all of these. The log of 108 is about 2.0. Log of 150, about 2.2. Log of 228 is about 2.4. Log of 779, 2.9. 1430, 3.2, 2880, 3.5. Why am I rounding so much? Normally I like to have a lot of decimal places. Why am I rounding so much here? It's because we're just plotting these on a number line. We don't know exactly what this is anyway on a graph. We just need to get enough numbers to give us a good approximation. We can plot it. So this is Venus. 2.2 is Earth. That's like 2 1/5. 2.4 is Mars. 2.9 is Jupiter. Saturn is 3.2. And Uranus is 3.5. There we go. And Pluto would be somewhere if it was a planet. So graphing this on a log scale is much easier than if we tried to graph this on a linear scale. Okay. I think I actually have it somewhere that I could quickly pull it up. If I could show you what it looked like on a linear scale. So on a linear scale, it looks like, see if I can do this. A little magic on the fly. This is from our textbook. You plugged all of these onto a linear scale. Actually, you can kind of see it okay, but it's much harder to graph. Our log scale is much more clearer, and the book's log scale is a little nicer than mine. All right, again, this is the log of the distance. It's capital X's, but everything's all bunched in here, kind of hard to see. or a linear scale. That's basically what we have going on here. One more thing we'll talk about here are semi-log plots. So on the number line, we can do a log scale, but on a normal graph, right, we have X's and Y's. So usually for a semi-log plot, we'll plot X like normal, but we'll do capital Y, which is the logarithm of Y, right? So we usually graph capital Y. This is called a semi-log plot. A full log plot or a log-log plot, yeah, it's called a log-log plot, would be logarithms on both X's and Y's. So anyway, below our two stock charts showing the Dow Jones Industrial Average from 1915 to 2023, we don't adjust for inflation here. And we're going to look at a few things here. Again, here's the linear model. It's linear because, again, we have the year on the bottom. And on the top, it's just the DJIA. Growing linearly, right? Add 5,000, add 5,000, add 5,000. Again, you can see these shaded areas are recessions. And over here, this is the Great Depression. Great Depression doesn't look so great to me. What's the big deal? It's just a little bump in the road. I don't know what people were complaining about back then. Well, that's the problem with linear models for exponential data, right? Money in general and like stocks in general, right, are basically exponential functions. Now, there's a lot of randomness in the short term, but in the long term, they're basically exponentials. You can't see anything down here. But let's look at the semi-log plot. The y-axis, right, starts at 100, gets multiplied by 10, gets multiplied by 10, gets multiplied by 10. This is now showing, right, if capital Y is 2 here, 10 squared. Capital Y is 3 here. Capital Y is 4 here. Capital Y is 5 here. This is a semi-log plot now. And, oh, okay, I guess the Great Depression actually did drop quite a bit. I guess maybe they were on to something. Let's compare 2008. 2008, the housing crash. Looks really bad here. It was pretty bad. But compare these two, 2008 with Great Depression. You can get a better picture of what's going on with a semi-log plot. All right. So this is really good for showing exponentially growing data. Again, I said, if we're looking on a linear plot, this is essentially growing exponentially. If we plug in exponential data on a semi-log plot, then it grows roughly linear. Let's not include the Great Depression on this model. That messes up our linear growth. But yeah, usually if we have exponential data and we put it on a semi-log plot, it'll look roughly linear, which is really nice. Okay, so again, the y-axis, you can see that one's growing linearly, one was growing exponentially. You can see the recessions. Recessions are all the periods highlighted in. All right, I don't think this is completely accurate because there wasn't maybe an official recession around COVID, but maybe this should be shaded. I don't know. And an exponential function will look like a linear function if it's written on a semi-log plot. And then again, we compare the Great Depression and the housing crash of 2008. And again, yeah, on a linear plot, Great Depression doesn't look so great. But in reality, yeah, it's a big tumble. How long did it take to get back here? 20 years? Oof. We can see the data a lot more with this semi-log plot. I love semi-log plots. And that's the end of the section. Okay. Hope you liked this section. Otherwise, well, maybe at least you learned something. Have a good rest of your day. Bye-bye.